Okay, I love this lesson. This is one of my favorite things to do in all of algebra. We're going to solve systems of equations. Now, let's just take a step back and remember how we solve a equation. Let's say we have 3x plus 4 equals 17. Well, we know how to solve this. Cross the line, change the sign, do the same thing on both sides, subtract the 4 over. So we'd have 3x equals 13. Divide the 3 over, and we'd have x equals 13 over 3. Okay, so that's no problem. We know how to do that. However, if we look up at the top, there's something fundamentally different about those equations. In those equations, there's both an x and a y. The one we just solved, there was only an x. There was only one variable, but in the top, there's two variables. And here's something very important you got to know. If there's two variables in it, you can't solve it, all right? If there's more than one variable, it can't be solved. We can't pinpoint it down to a single answer. So what we have to do is we have to kind of add something else into this. And that something else that we're adding into this is a second equation. Because when we're solving systems of equations, I'm not just looking for the place where the first equation is true or the second equation is true. I'm looking for the place where they're both true. And so we're going to use something, some really cool properties of algebra to be able to actually solve this. But remember, if there's more than one variable, we can't solve it. So what we're going to have to do is we're going to have to eliminate a variable. Now, there may be some shortcuts to this, and if you see ways that are a little bit quicker, I challenge you, go ahead and take them, but I'm going to show you a method that is always going to work. Again, there may be a quicker way, use it if you find it, but here's a way that will always work, okay? What I'm going to do is, I need to get one of those letters to eliminate, either the x's or the y's, and a good trick to do here is I'm going to multiply. I'm going to multiply the top by the bottom and the bottom by the top. When I say that, what I mean is I'm going to multiply the entire top equation by this first number right there. So that's going to be a 3. And then I'm going to multiply the bottom by the top. So I'm going to multiply the the bottom equation by this first number right there in the top. So I'm going to multiply the top by the bottom and the bottom by the top. Now when I do this, I've got on the top just distributive property, 12x minus 6y equals negative 42. And on the bottom, 4 times 3x, that's going to be 12x minus 4y equals negative 32. Okay, now, what I like about this is that the x's have the same coefficient in front. They're both 12s. And what I'm trying to do is I'm trying to get one of them so I can add it or subtract it, but I'm always going to say add. Add together to get 0, because if it's 0, then that letter would eliminate. We could eliminate those x's if they were just 0. So 12 and 12. Well, the problem is they're both positive, and a positive 12 and a positive 12 equals 24. I need one of them to be negative. So I'm going to choose either the top equation or the bottom equation, whichever one I want, and I'm going to change all the signs. I'm going to do that because what I'm doing algebraically is multiplying or dividing by negative 1. But all I really have to do is change the signs. So what I'm going to do is on the top, I'm just going to change the signs. And you can do top or bottom, but I'm going to change the top just because that's what I want to do. Negative 12x, this becomes a positive 6y, and this becomes a positive 42. Now, watch what we can do. Let's just add these straight down. We're really using the additive property or addition property of equality if you want to know. But we're just going to add these straight down. Negative 12x plus 12x is 0. 6y minus 4y is going to be 2y. And 42 minus 32 is going to be 10. Well, this is a one-step equation now, and I've only got one letter, so I can actually solve this. Divide by 2, and I'm going to get y equals 5. Now, I'm not quite done because I need to know what x is as well. So I can pick any of these equations, whichever one I think looks easiest. I think this second equation looks the easiest. No real reason, that's just what I think. So I'm going to use that. 3x minus y equals negative 8. And if I put y, I know my y is 5, so if I just substitute 5 in for y here, now I can solve this. Add the 5 over. 3x equals, that looks like negative 5, 8 plus 5 is a negative 3. Then divide the 3 and we're going to get x equals negative 1. So my answer, the one answer that works for both of these is the point negative 1, 5. Pretty cool. Let's look at the next one. Again, we're going to multiply the top by the bottom and the bottom by the top because we have to eliminate one of those variables. So if I multiply the top by 3 and the bottom by 5, the top, distributing that, that's going to be 15x plus 9y equals negative 30. And on the bottom, 15x plus 25y equals negative 30 again. Okay, now the x's are almost ready to eliminate because they're both 15s and they're going to give me 0, but I have to change the sign so that one's positive and one's negative. Change them anywhere. Again, I'm going to change them on the top. Negative 15, this is going to become a negative y, and this is going to become a positive 30. So let's add them now. Negative 15x plus 15x is 0. Negative 9y plus 25y, that's going to be 16y. And negative 30 plus 30 is going to be 0. Divide by 16, and we're going to just get y equals 0. Now, choose whatever equation you like. I like the top one. So I've got 5x plus 3y equals negative 10. Substitute 0 in for y. So I've got 3 times 0. Well, that's just 0. So I've really got 5x equals negative 10. I divide by 5, and I'm going to get x equals negative 2. So my ordered pair, my solution here is going to be negative 2, 0. X always goes first. Negative 2, 0. That's my solution. Okay, and that's the one solution that works for both the top and the bottom equation. All right. Now let's look at some special situations here. Okay, so I've got a system of equations up here again. I'm going to do the same thing I've done before. Multiply the top by the bottom and the bottom by the top. So I'm going to multiply the top by 3 and the bottom by 2. So on the top, that's going to be 6x plus 12y equals 36. On the bottom, distribute the 2. 6x plus 12y equals 36. Change the signs on either the top or the bottom. I'll choose the bottom this time. Negative 6x, this becomes a negative 12y and a negative 36. All right, let's add them. 6x minus 6x is 0. It eliminates. 12y minus 12y is 0. 36 minus 36 is 0. So I've got 0 equals 0, like literally everything has just disappeared. Well, let me ask you a question. When is 0 equal to 0? Always, right? 0 is always equal to 0. So now I'm not going to say all real numbers for this, but what I am going to say, if it's always true, I'm just going to say that's infinitely many solutions. Okay? Infinitely many solutions. There are an infinite number of ways that I could solve this. And if you remember back to the lesson on graphing, this was, if I could sketch a graph real quick, these were two lines that were right on top of each other. Okay? Infinitely many solutions. Let's look at the next special situation. Okay, once again, multiply the top by the bottom and the bottom by the top. So my equations are just about the same that they were last time. Multiply the top by 3, that's going to be 6x plus 12y equals 36. Multiply the bottom by 2, 6x plus 12y equals 30. Okay, again, the x's are ready to eliminate almost. They're both positive 6, so I need to change the signs on one. I'll change it on the bottom. Negative 6x, that's going to become a negative 12y and a negative 30. Okay, 6x minus 6x is 0. 12y minus 12y is 0 again, and 36 minus 30 is going to be 6. Okay, so, well, that looks a little strange because that says 0 is equal to 6. 0 is the same thing as 6? I don't think so. 0 is not the same thing as 6, and it never will be. So this one is going to also be unique. This one is actually no solutions. 0 is never equal to 6, so there is no number that we can put in for x and y, no combination that will make that system be true. So this is just no solutions. All right, so I think you got it. Remember, we have to eliminate one of those letters before we can solve it, but we can do that. There may be a shortcut, but what will always work is multiply the top by the bottom and the bottom by the top. And then watch out, you might have to change the sign. If they're both positive or they're both negative, you're going to have to change the sign so that you can get it equal to 0. That's what we're looking for, 0 in front of one of those exponents. All right, I know you got it. Good luck.